December 2025, Northern Ireland. A man stands in the darkness with a telescope pointed at the moon, and then, without warning, a flash. A silent explosion, brighter than the sun. What Andrew Marshall Lee captured that night wasn't just rare footage. It was a warning. A reminder that our cosmic neighborhood is far more dangerous than we like to believe. This is the story of a rock traveling 100 times faster than a passenger jet. And what happens when it meets the surface of another world? Most people will never see what Andrew saw, not because it's impossible, but because it requires patience, precision, and a willingness to stare into the void for hours on end, waiting for something that might never come. Andrew is what you'd call a celestial hunter. He doesn't chase storms or wildlife. He chases light, fleeting, violent bursts of energy that last less than a second. These are moments that most of humanity will sleep through, scroll past, or simply never know existed. But for Andrew, they represent something profound, a connection to the wild, untamed nature of space itself. On that cold December night, his camera was locked on the moon's terminator, the boundary between light and shadow, where contrast is sharpest, where impacts are easiest to spot. This narrow band of twilight on the lunar surface is where celestial observers focus their attention, because here, even the smallest flash becomes visible against the stark division of brightness and darkness. He'd done this dozens of times before, watched, waited, seen nothing. Hours upon hours of recorded footage showing only the steady, unchanging face of the moon, the craters, the Maria, the ancient seas of frozen lava that give our nearest neighbor its familiar patterns. But this time was different. At precisely the moment his recording began, a meteoroid, no larger than a basketball, entered the moon's gravitational pull at 45,000 miles per hour. Think about that. Speed for a moment. A commercial airliner cruises at around 500 miles per hour. This rock was moving 90 times faster. No atmosphere to slow it down. No friction to burn it away. Just raw, unfiltered kinetic energy, meeting ancient stone. The result? A flash so bright it could be seen from 250,000 miles away. And Andrew caught it all, frame by frame, second by second, a cosmic collision frozen in time. The kind of event that happens constantly across our solar system, but rarely with a witness, rarely with someone pointing a camera at exactly the right place at exactly the right time. Let's talk about what actually happened up there. When that rock hit the moon, it wasn't just a collision, it was a transformation of matter itself. At impact, speeds exceeding 61,000 kilometers per hour, the meteoroid didn't simply crack the surface, it vaporized instantly. The kinetic energy was so immense that both the incoming rock and the lunar regolith beneath it were converted into plasma, a superheated gas hotter than the surface of the sun. For a fraction of a second, a miniature star was born on the moon. The explosion excavated a crater, threw debris hundreds of meters into the airless sky, where it would arc gracefully before falling back down in slow motion, unimpeded by air resistance. And it released a shock wave that rippled through the ground like a stone dropped into still water, except there was no sound, no roar, no thunder, just silence. Because the moon has no atmosphere to carry the noise. If you'd been standing a kilometer away, you would have felt the ground tremble beneath your feet, but heard absolutely nothing. That's the eerie reality of impacts in space. They're catastrophic and utterly silent. It's a phenomenon that challenges our earthly intuition. We expect big events to be loud. We expect destruction to announce itself. But in the vacuum of space, violence happens in perfect, absolute quiet. Now, Here's where it gets interesting. This wasn't just any random space rock. Scientists believe this meteoroid, and thousands like it, originated from something called 3200 Phaethon. Phaethon is what's known as a rock comet, a strange hybrid object that behaves like a comet but looks like an asteroid. It's one of the most peculiar objects in our solar system, defying easy categorization. Every year, as Earth passes through the debris trail left by Phaethon, we get the Geminid meteor shower, those beautiful streaks of light that paint our December skies. They're the remnants of this ancient wanderer, burning up in our atmosphere at altitudes where the air is still thin enough that they pose no threat to us below. And in December 2025, the Moon did the same. It passed through Phaethon's debris field. Except unlike Earth, the Moon has no protective shield, no atmosphere to incinerate incoming threats. Every rock that comes its way lands. Every fragment, no matter how small, completes its journey from the depths of space to the solid surface below. Here's the uncomfortable truth. The Moon is covered in scars. Billions of years of bombardment have turned its surface into a battlefield, a chaotic archive of cosmic violence. Craters within craters, overlapping impact zones, mountains formed from ejected debris that was thrown so high and so far it piled up into peaks taller than anything on Earth. And it never stops. Every year, the Moon is hit by thousands of meteoroids. Most are small, grain of sand small, creating impacts too tiny to see from Earth. But some, like the one Andrew filmed, are large enough to leave permanent marks. New scars on an already scarred face. In 2013, NASA recorded an impact so powerful, it created a flash visible to the naked eye from Earth. The meteoroid weighed just 40 kilograms, about the weight of a large dog, traveling at 90,000 kilometers per hour. The explosion? Equivalent to 5 tons of TNT. Enough energy to destroy a building, enough brightness to outshine the stars around it. And that's the problem. Because humanity isn't just observing the Moon anymore, we're planning to live there. Right now, space agencies around the world are designing the International Lunar Research Station, a permanent base on the lunar surface, a foothold for deep space exploration, a laboratory for studying the cosmos, a stepping stone to Mars and beyond. It represents the next great leap in human exploration, the fulfillment of dreams that have existed since the first person looked up at that pale light in the night sky and wondered what it would be like to walk there. But here's the catch. The Moon doesn't have an atmosphere to protect it, no magnetic field to deflect radiation, no warning system for incoming debris, which means every structure we build there, every habitat, every laboratory, every landing pad will be exposed, vulnerable, out in the open with nothing but engineered materials, standing between the people inside and the void outside. One well-placed impact could puncture a pressurized module, destroy critical equipment, end lives. And unlike Earth, where most meteoroids burn up harmlessly in the sky, becoming nothing more than shooting stars for children to wish upon, on the Moon, they all get through. So the question isn't if another impact will happen, it's when. And will we be ready? This is why Andrew's footage matters. Every impact he records, every flash he captures, adds another data point to our understanding of lunar bombardment rates. How often do these strikes occur? What sizes are most common? Which regions are safest? Are there patterns to the impacts? Do certain times of year see more activity than others? These aren't academic questions. They're survival questions. They're the difference between building a base that lasts for generations and building one that becomes a tomb. Engineers designing the Lunar Research Station are already considering impact shielding, reinforced walls made from lunar regolith itself, underground habitats carved into the rock, protected by meters of stone overhead. Early warning systems that track incoming debris, though their effectiveness is limited by the sheer speed at which these objects travel. But there's only so much we can do, because unlike Earth, where we can predict asteroid trajectories years in advance, where we can see the big threats coming and potentially do something about them, the Moon is constantly pelted by smaller, untrackable fragments. Objects too small to monitor, too numerous to avoid. Phaethon alone leaves behind millions of particles, each one a potential threat. And Phaethon is just one of thousands of objects crisscrossing the inner solar system, each shedding debris, each contributing to the cosmic shooting gallery that is near-Earth space. So what do? We adapt. We build smarter, deeper, with redundancy and resilience baked into every design. We accept that living on the Moon means living with risk, but we do it anyway, because the Moon isn't just a destination. It's a proving ground, a place where we learn to survive in the harshest environment imaginable before we venture even farther. To Mars, to the asteroid belt, to the moons of Jupiter and Saturn, to places where help is months or years away, where self-sufficiency isn't optional, it's mandatory. If we can make it on the Moon, we can make it anywhere. Andrew Marshall Lee didn't set out to change space exploration. He just wanted to see something incredible. And on that December night, standing in the cold Irish darkness, he did. He watched as a rock, older than human civilization, older than complex life on Earth, met its violent end on another world. He captured a moment that had happened billions of times before, and will happen billions of times again. But this time, we saw it. We recorded it, studied it, learned from it. And that's what makes us different from every other species that's ever existed. We don't just survive our environment, we understand it. We take the chaos of the cosmos, the randomness, the violence, the indifference, and we turn it into knowledge, into preparation, into progress. The Moon has been struck by countless impacts over its long history, but soon, it won't be just a dead rock absorbing the blows. It'll be home, a place where humans live, work, and explore, where we take our first real steps toward becoming a multi-world species. And when the next flash lights up the lunar surface, when the next cosmic bullet finds its mark, we'll be watching, recording, learning. Because that's what we do. We witness the universe in all its beauty and terror. And we move forward anyway. The Moon is waiting, and so is the rest of the cosmos.